Okay, welcome. This is an optional video for you to watch on Pascal's Triangle. You only had to watch this video if you did not understand the Pascal's Triangle activity that was on the Moodle. So if you did not understand parts of that activity, then that's what will be explained in this video. So to start with, this is Pascal's Triangle. It's made up of a series of rows and diagonals. The first row is actually called row 0. The second row is actually called row 1. Then you have row 2, row 3, row 4. The first diagonal is called diagonal 0, or these are term 0. Diagonal 1, diagonal 2, diagonal 3, this would be diagonal 4. In order to complete the next line in Pascal's Triangle, what you can see is that all rows start with a 1 and all rows end with a 1. The second term, you can see in row 1, the second term is 1. In row 2, the second term is 2. In row 3, the second term is 3. In row 4, the second term is 4. So in row 5, the second term is 5. And that's the same as the second last term. To get these two numbers, if you take a look at a pattern, diagonal 2 goes from 1 to 3 to 6. So from 1 to 3, you add 2. From 3 to 6, you add 3. So the next pattern would be to add 4. So that would be a 10. And once again, 1, 3, 6, that number would be a 10. So that's how you'd fill the next line of Pascal's Triangle. So each row starts and ends with a 1. The second and second last numbers in row n are n, just like the second and second last number in row 5 is 5. So the second and second last numbers in row 8 are 8. In the computer activity, you can ignore the patterns of 11 activity and the hockey stick pattern activity, and you move to the palindrome property. The palindrome property just means that the row is symmetrical. It's the same going forwards as it is going backwards. So right down the middle, it's symmetrical on both sides. So if this was a row in Pascal's Triangle, 1, 1491, 364, 1001, there you go. You can see there's the middle. So it's going to go down the same way it came up. So that's 3003 there, 3003 there. That's 2002 there. That would be 2002. Next one is 1001. Next one is 364. Next one is 91. Then 14. And then the last one is 1. Now, in Pascal's Triangle, another way that you can get these numbers is by using NCR. So N is the row number, R is the diagonal number. So since this number is row 5, diagonal 0, you can get this number by using 5C0. This is row 5, diagonal 1, so you can get this number as 5C1. This is row 5, diagonal 2, So you can get this as 5C2. This would be 5C3, 5C4, and 5C5. Similarly, if you wanted to do the sixth row, you could start with 6C0, 6C1, 6C2, all the way up to 6C6. So each term in Pascal's triangle is found using NCR, where N is the row and R is the diagonal, or also what we call the term. So if you wanted to find the first 5 numbers in row 17, you would calculate 17C0 for the first term, 17C1 for the second, 17C2 for the third, 17C4 for the next one, and 17C3, and then lastly 17C4. And those numbers would be 17C0 is 1, 17C1 is 17, 17C2 is 136, 17C3 is 680, and 17C4 is 2380. Okay, so the next pattern was in regards to the sum of the rows in Pascal's triangle. So over here, row 0, the sum is equal to 1. In row 1, the sum was equal to 2. In row 2, the sum of the terms was equal to 4. In row 3, 1 plus 3 plus 3 plus 1 is equal to 8. In row 4, 1 plus 4 plus 6 plus 4 plus 1, the sum is 16. Row 5, 1 plus 5 plus 10 plus 10 plus 5 plus 1 is equal to 32. And what you should notice is that these are all powers of 2. So the sum of the terms in any row of Pascal's triangle is found by 2 to the n, where n is equal to the row number. So the sum of the terms of row 18 would be equal to 2 to the 18. And this is useful for a question like this. 5 students have signed up for the Blaise Pascal fan club. The first meeting is today at 4, but the weather is a little stormy. How many combinations of people might show up for the meeting? So in this case, there are 5 people, but it could be none that show up. Or, out of the 5 people, 1 could show up. Or, out of the 5 people, 2 could show up. Or, out of the 5 people, 3 can show up. Out of the 5 people, 4 can show up. Out of the 5 people, 5 can show up. So rather than doing all of that calculation in your calculator, you can just do 2 to the 5. Another way of looking at this is there's 5 people and each person has 2 outcomes. They can either come or not come. So person 1 can come or not come. Person 2 can come or not come. Person 3, come or not come. 4 can come or not come. 5 can come or not come. So once again, that's still equal to 2 to the 5. So there's a couple different ways to answer this question. Either which way, it's 2 to the 5. My brother has given me a list of 10 CDs that he would like for his birthday. I have not decided how much money I will spend on him or even if I will buy him anything. How many combinations of the requested CDs might I purchase? So once again, out of the 10 CDs, I might buy him none. Or out of the 10 CDs, I might buy him one. All the way up to, out of the 10 CDs, I might buy him all 10. So that would be equal to 2 to the 10. And 2 to the 10 is equal to 1024. So you use these types of questions when you know the N, but the R can be any value or all values, really. So again, the N is always 5, but we didn't know how many people can show up, so you have to consider all the cases of R. Here the N was 10, but we didn't know how many CDs we were going to buy. We could have bought none or all the way up to all 10. So that's when you would use that method of solution. So the next pattern that you need to know about is the additive property. So in the additive property, in order to get the next row, what you can do, rather than looking at this pattern to get this 10, you could have gotten this 10 from taking 4 and 6 and adding them to get 10. So any value is found by taking the two terms above it and adding them. So if you wanted to get row 6, it's going to start with a 1. So this is row 6. The next term is going to be 1 plus 5 is 6. The next term is going to be 5 plus 10, which is 15. The next term is going to be 10 plus 10, which is 20. The next term is going to be 10 plus 15, 10 plus 5, which is 15. The next is going to be 5 plus 1, which is 6. And the last one is going to be 1, nothing to add over here, so it's going to end with a 1. So if you know the previous row, the numbers in each row are formed by adding the two terms above it. So row 6 we found was 1, 6, 10, 15, 20, 15, 10, 6, 1. Okay, if you didn't quite understand that, to get row 7, all right, you add 1 here. There's nothing to add on the other side, so it's going to start with a 1. 1 plus 6 is 7. 6 plus 10 is 16. 10 plus 15 is 25. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 10 is 25. 10 plus 6 is 16. 6 plus 1 is 7. And 1, nothing to add on this side, would just be 1. We're going to finish the video in the second half because we are out of time. So please do not forget to watch the second part of the video.